All right, kids, we're going to look at section 5, which is the trapezoidal rule. And what this does is it gives us another shape to find the area under curves with. So if you'll think back to when we were doing LRAM, MRAM, and RRAM and all those RAMs, MRAM, that midpoint one, seemed to be the most efficient way to find the area under the trapezoid. And if you think about it, though, or the area under the curve, but if you think about it, a trapezoid may even be better. For example, if we have this, some shape here, and I look under this shape with rectangles, if I look under the shape with a rectangle, then I'm going to have space out above the rectangle and below the rectangle in the shape, and it's maybe not going to be a great fit. But if I come in here and I use a trapezoid, then I can get a shape like this, which eliminates a lot of space that could be wasted. So this is actually going to be a really handy way to find areas under curves. And we might not always use it, it just depends. But to approximate that, we've got this formula where we're going to use to approximate the integral, definite integral from a to b of fx dx. We've got this formula here, and it's t for trapezoid, and it's this guy right here. And a is where we start, b is where we stop. Okay, and we're going to have n sub-intervals, and so what we're going to do is we're going to take the stop minus the start, divide that by n, and then we're just going to look at all the different little x values for the sub-intervals and figure out what the y values are that match and put those in here and do our math, and we'll get an approximation. Or we could do the LRAM plus RRAM divided by 2. So, you know, that's another way that we could get a really good approximation. So this is the setup. There's no really example on this one, but this is the formula that we're going to use, and we'll look at how that formula is used on the next slide. All right, we're going to use the trapezoid rule, which we just saw a slide on, and we've got a special guest with us today at KSteve320.
Trapezoids are awesome.
Yeah, and so she's just going to do the handwriting. You'll notice a difference in handwriting. I'm going to let KSteve do the writing, and it'll be amazing how much better it's going to be.
No pressure to me.
No pressure at all. Okay, so trapezoid rule, what we're going to do is we're going to take that formula that we just wrote down, KSteve, it's just right here if you want to borrow, and we're going to use it to find the area under the curve of x squared from 1 to 2. And then we're going to also, after we do this, you get to punch it in on your calculator and double check how close the approximation is.
Alrighty.
So here's what we're going to do. We're going to find how many, we want 4 intervals from 1 to 2.
So from 1 to 2.
From 1 to 2, we want 4 equal intervals.
So like divide
So
in half.
divide in half. There you go. So 1.5, 1.25.
So each one is 0.25.
You got it. Each one's 0.25. Okay.
That's...
But we need all those intervals. So go ahead and fill in that last one, 1.75. Excellent job. Okay. Now, here's what we're going to do. We're going to start with 1.
Okay.
And we're going to put it in for y naught. And what that means is x squared. We're going to put 1 in for x squared.
So 1 in for x squared gives us 1.
Yes, that is correct.
Okay. Because actually, like it might be more helpful maybe to have a picture drawn. Like we're going to have this kind of a curve situation going on, and so that's part of a parabola. And so up here, the y value there is 1.
That is correct.
Right?
Yes, that is.
Okay.
Yep. So 1 plus. And then we're going to do 1.25 squared. I'll do that one on here. So,
okay, 2 times that?
2 times, yes,
yeah.
2 times 1.25. So 1.25 squared is...
Square before you multiply by 2.
Yes, is 1.5625.
Okay.
All right, plus 2 times 1.5 squared, which is 2.25.
Okay.
Plus, and then 2 times 1.75 squared. which what happened?
I just was writing instead of like actually
Oh,
reading.
it's 3.0625.
Okay.
That can't be good. Look what just happened over there. Okay, plus, and then nothing else, just the last guy now. So
Yeah.
2 squared and
That's 4.
4. Okay. All right, now, we got to figure out this h over 2. And h is the stop minus the start divided by the number of intervals. So we stopped at 2.
Oh, okay. So like we stopped at 2.
Yeah.
So 2 minus 1.
2 minus 1,
but
all
there's
over
4
4.
intervals.
Right. What's that equal?
1/4.
That goes in the very front.
And so as long as we had it written out like this, we could say it was like 0.25, right? Because that's how far apart these are?
Mm-hmm.
Okay.
Mm-hmm. Mm-hmm.
So
So 1/4. So 1/4.
over 2?
H
over 2?
Yeah, h over 2. So 1/4 over 2, which is like 1/8.
Yes, it is like 1/8.
Why are you?
No, I didn't. I don't know.
feel like you were getting ready to do it.
No.
Okay, all right. So 1/8 times all of that stuff. Just
Yeah,
go ahead.
1/8 times all.
Crank it out.
I don't know.
Okay.
You'll have to do it yourself.
All right. So
And while you're doing that, you're
1/8.
just typing
I'm
it
just
in.
gonna type
just
it
some
in.
parentheses. Like notice how we put 2's in the middle ones, but like the end points don't have 2's in front. That's how you know whether to times
Right.
something by 2 in the middle or not.
right, just the
So-
endpoints don't. 2.25 plus 2 times 3.0625 plus 4. I get 2.34375.
You sound proud of yourself.
Pretty proud of myself because I didn't have a typing error, which always happens.
Yeah.
But now you're here writing, and I don't have to do 5 things at once. Now,
Yeah.
go ahead and this is your trapezoidal approximation.
Yes.
Now, you on your own get to run int, and you're going to write it down, and you're going to say how close you are. You know, how close is this approximation? And I think you're going to discover that it's pretty close.
Pretty close.
Pretty close.
Pretty close.
Yeah, pretty close.
Because the trapezoidal estimate is the best of the estimates.
It's the best
right?
of the estimates.
Yes, so, okay.
All right, there you go. All right, here we are. Trapezoid rule again, another example. And so let's just get a real quick refresher of what that looks like. And it's going to be h over 2 times y0 plus 2y1 plus all the other parts plus 2y n minus 1 plus y n. Okay? And h is equal to b minus a divided by n. So this is our setup. Well, what are we dealing with? We are working on the sine curve. And specifically, we're working on the sine curve from 0 to pi. Okay? So we're going from 0 to pi. And a real quick refresher, that sine curve looks like this. Oh, made it, okay? And n is 4, so we need 4 separate intervals of equal length. So half of pi is pi over 2. Half of that is pi over 4. And so it's pi over 4, pi over 2, 3 pi over 4. And what we want is the height. We need the height here. We need the height here. We need the height here and over here. So this guy is going to be y1, y2, y3. Here's y0, and here's y4. And once we have all those, I've been negligent. This is Jordan is my assistant today, football star, basketball stud, and he's going to make me look better just by gracing me with his brilliance. So here we go. H over 2. Well, b minus a over n. This is going to be pi minus 0 over 4, which is pi over 4. And that goes over 2. So t is equal to pi over 4 over 2 times the sine of 0, which is 0, plus the sine at pi over 4. Well, that's the square root of 2. So 2 square roots of 2 over 2. 2 times that. Plus the sine at pi over 2. That's 1. 2 times 1. Plus 3 pi over 4, the sine at 3 pi over 4, which is square root of 2 over 2. Plus, and then the last one is the sine at pi, which is 0. So here's what we're working with. This is going to be pi over 8 times, and then if you'll notice right in here, zeros go away. They're gone. The 2's on these guys cancel out. They're gone. So I'm just left with 2 square roots of 2 plus 2. And you can punch it in on a calculator. I'll do it though, don't move.
Oh, okay.
So when I punch that in on a calculator, pi divided by 8, and then times 2 square roots of 2 plus 1. So I get 1.89612.
1.89612.
Good job, Jordan. Now, your job is to, on your calculator, nint this guy out. Finint, as it were. And once you nint this guy out, take a look and go, okay, hey, how close is this to 1.896? Is it really close or not close at all?
What do you think?
I don't know. Hey. So anyway, there you go. Trapezoidal rule. Okay, Simpson's rule is a close relation to the trapezoid rule, and it can be used as well to approximate areas under integrals. The formula, though, is just a wee bit different. So, but it still works out pretty good. Do you believe it?
Oh, I definitely believe it.
Do you believe it?
The monkey does.
The monkey does. Okay, so here's our formula using Simpson's rule. All right, it's this S, h over 3. It's found the same way. H is b minus a divided by n. And then y0 plus 4 times the first guy, 2 times the second, 4 times the third, and so on and so forth. Now, the trick on this is you have to have the correct number of intervals, or it doesn't work. If you don't have the right number of intervals, you can't use Simpson's rule. Okay?
Why Simpson?
Well, because he's the guy that kind of got it out there and made it famous. So, here we go. We're looking at 5x to the 4th, and if we look at this graph, 5x to the 4th looks something like this. It's really similar to that. It might not be exactly that. And we're going to go from 0 to 2. And we want to divide that into 4 equal spaces. So here's 1, here's 1/2, and here is 1.5. Very good. 3 halves, we'll say. Okay? So here is y0, here is y1, here's y2, here's y3.
Y4.
And y4. Yes, good job, Jordan. All right, so here's what we're going to do. B minus a, h is equal to b minus a divided by 4. So this would be 1/2. And when we set up our Simpson's rule, we're going to have 1/2 divided by 3 times, and then y0. Well, when I put 0 into this equation for x, when I put 0 in right there, I get what?
You get 0.
You get 0 plus 4 times y1, and that's a half. So 4 times 1/2 to the 4th times 5. I'm just going to punch that in real quick.
Come on, you can do that one in your head.
0.5 to the 4th times 5. So that's 0.3125.
0.3125.
Plus, and then 2 times y2, right here, 2 times y2. Well, that's 1 to the 4th, so that's going to be 5. Plus, and then I'm over here now, 4 times 3 halves. Now put 3 halves in here for x, so 5 times, so 3 halves squared, or to the 4th, whoops, times 5, and that's going to be 25.3125.
25.3125.
You get a cookie.
Plus, and then 4 in for that guy, so 5 times 4 to the 4th, which is 1,280.
1,280.
And then what we're going to have is 1/6 times all of those guys. So 0, we don't need to worry about him. 4 times 0.3125 is 1.25.
1.25.
Plus 10 plus 4 times 25.3125, which is 101.25 plus 1280. And whatever this answer is should be the area under our curve. So 1/6 times all of that. And I get 232.083.
232.083.
And so there you go. There's Simpson's rule.